Welcome to Graphing Linear Inequalities. Let's get started. Now, graphing inequalities is going to be similar to graphing linear equations. You still have to have your equation in y equals mx plus b form so you can identify your slope and your y-intercept. It's just you'll have a sign here instead of the equal sign. There's two extra things that you have to worry about. The first one is that your line, it can be a solid line, but it could also be dashed, and we'll look out for that. The second thing is that you're going to have shading on your graph. So let's do this first example. Y is less than 2x minus 3. We have our slope, which is 2, and our y-intercept, which is negative 3. So we plot that y-intercept onto our graph, negative 3, and then we move the way the slope tells us to move. Our slope is 2. Now, if there's not anything under the 2, it's like you have 2 over 1. So we rise 2, up 1, up 2, and we move to the right 1. So that's where our next point goes. Up 2 over 1, up 2 over 1, and so forth. Now, before we draw our line, we have to check out this sign right here. It's y is less than. Since it's not equal to, our line is going to be dashed. Now the next thing we have to figure out is where do we shade, on this side of the dashed line or on this side. The most accurate way to figure this out is by testing a point 0, 0. Remember, this is your x and this is your y. So if we plug 0 in for x here and 0 in for y here, then we have 0 is less than 2 times 0 would be 0 minus 3, which simplifies into 0 is less than negative 3. Now, is this true? No, 0 is not less than negative 3. That means your point 0, 0 on the graph is not in the shaded region of this inequality. So we're going to shade on the other side. So let's try this next example. This equation is not in slope-intercept form, so we need to change it. We want to move this 2x, this negative 2x, over to the other side of the inequality sign. So this cancels, and we have y is less than or equal to 2x plus 1. We can graph this now because it's in the slope-intercept form. So we find our y-intercept plus 1. We plot that on our graph right here. And then we move to the next point with our slope, which is 2. Remember, 2 over 1, that's how we move. So we move up 2 over 1. We put that right there. Up 2 over 1, up 2 over 1. Now let's take a look at our sign. There's an equal to, it's less than or equal to. So that means our line needs to be solid, not dashed like it was in the previous example. The last thing we need to do is figure out where we're going to shade on the graph. Remember to use 0, 0 as your testing point. This is the most accurate way to figure out where the shading goes on the graph. So you plug 0 in for x and you plug 0 in for y, and that gives us 0 is less than or equal to 2 times 0 is 0 plus 1. And we simplify that, 0 is less than or equal to 1. This is true. So that means this 0, 0 point on our graph will be on our shaded region. So we can shade here. So let's sum up the steps to graphing a linear inequality. The first 3, as you'll see, are the same as graphing a linear equation. You still want your equation in slope-intercept form so you can identify your slope and y-intercept. Then you want to plot your y-intercept on the graph, move to the next point with your slope using rise over run. The two different steps with the inequalities are to determine whether or not your line is solid or dashed. And remember, if you have a less than and equal to or greater than or equal to, then your line would be solid. If it's not equal to, then it's dashed. And the last step is to use the point 0, 0 to test where to shade. Plug this 0, 0 back into the equation, and if it's true, then that 0, 0 point is in the shaded region of your graph. If it's not true, then you don't shade where 0, 0 is on the graph. So this is the last video of the week. Remember, you're always able to go back, re-watch videos, pause, rewind, take notes to make sure that you really understand what we're doing this week. Thanks for watching. See you soon.